I love that.
All right. Okay, yesterday we kind of did that little activity where you're graphing, where you had those little slips of paper and you had to transfer. Does everyone still have that little slip of paper with your graphs? I would like that if you have it with you. Have it out. Okay, if you didn't get one, let me know. You do need to have it from yesterday. So that was that little slip right there. There was like 4 graphs. I think we got to like 2 of them maybe.
We got the 4.
All 4?
No, I got the 3 of them.
To the 4th one. Do we actually use the 4th graph?
Yeah.
Some people did. All right, put your name on it. I'll take it. Even if you didn't get to it. What? That was yours?
It might have been. Because I don't remember.
Okay, grab it when you're done. Okay, because when we're doing notes, just go get it. So, like, write a note down for yourself.
I don't think so.
This one?
Yeah, we're gonna keep those.
I kept it, I figured it was somebody's.
Yeah.
All right, I'll take those. I thought we had maybe one more graph we could do. Okay, that's fine. We'll take it, we'll just do some generic drawings today.
I didn't think that we were gonna keep those.
Lunch yourself, all right.
My bad, that my pencil ran out of my head.
You should wrote
It is your bad. It's not his bad.
Yeah.
It's not his bad.
So, like I know,
That's my bad. I mean, they were really easy. It was just, that's a cut. That's
Okay.
No, there's
Perfect. Good thing it's good.
Then your statement was on it.
I knew what I was doing. I couldn't use.
Here you go.
But it's obviously the
I remember which one.
Oh, okay. All right. Okay, here's what I'm going to put on the board. I'm going to put that little outline that we did yesterday. Yesterday we did a horizontal shift. Horizontal shift. That is our first step you should be doing. Now, I kind of warned you yesterday when I do this, on the steps, the order, sometimes I do the horizontal stretching first. I know it seems a little weird for some people. I like to stretch it and then I'll move it horizontally if I know I have both in the same picture. That's just like one of the things I've just learned over the years of doing it. Because for me, it was more difficult like moving it first and then figuring out that it was twice as wide and figuring out where those coordinates were. So I stretched it and then moved it. But for anybody, like if you just get the idea of how to do it, it really doesn't matter. But you're supposed to do horizontal shifts first. Second, you're supposed to do some type of stretch or shrink. And that's called a dilation, right? The hardest ones are the horizontals. Like when they stretch it like horizontally, like 5 times further, or like that's where you use a fraction, right? Where you go 5 times wider, or you shrink it like half as big. The horizontal always gets people. The vertical makes sense. Like the X numbers don't change, but the Y numbers did. So you're compressing, but the horizontal one really messes with people because it does move pretty drastically on that. The third type is some type of reflection. There was a couple groups yesterday that did have to do a reflection where you had the reflector of the x-axis versus the y-axis, just knowing which one's which. And then the last one that we did, last one, number 4, is that vertical shift. Now, I want to talk about why is this the order? We didn't get to do this yesterday. I just kind of threw it at you, said, hey, this is the order, you have to do it, blah, 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 right? But why would it make a difference? That's what I want you to think about. So let's say you had a problem where it did something like this, where it was, this is your function, I'll draw this here in a second. This is your original function on the graph, I'll put it in black and then we'll mess with it. So let's say that this is your picture. Alright, so here you go. Okay, let's say that's your picture, okay? If I'm going to mess with this, we're going to do a couple different things. Let's say I want to move it, let's say I want to reflect it across the x-axis, and I want to move it up 7. Okay? If you went out of order, so if you went out of order on this one, what will happen is that you would think that you're going to move it up 7 first. So this thing, like this dot will go up 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same thing, and then up 7, 1, 2, 3, 4, 5, 6, 7. All right, so you moved it out. This is kind of what it looks like if you did the vertical shift first. Then you would reflect it across the x-axis. So all those dots would go inverted to here. see. And it would be, what is that, 6? 1, 2, 3, 4, 5, 6. All right, so this is what it would look like if you went out of order. Right, you did the vertical shift first, then you reflected. That's not what the graph should look like. Because if you actually go in the order of operations for graphing, you have to reflect it first and then drag it. You're going to see that it's radically different. Like, it's a way different picture. Okay, so this is the one it should be. I'm going to try to put this in blue so you can see this. So did everyone understand how I just did that, how I moved it up and then reflected? That is not the order, by the way. So this was the final answer. That's what you should have got if you did it wrong. But the real answer is you should reflect first. Okay, you should reflect first, like such, then move it up. Because that's the order you should go in. Well, that means if I'm going up 7, 1, 2, 3, 4, 5, 6, 7, up 7, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 7, and then 1, 2, 3, 4, 5, 6, 7. It's a really big difference. Like, can you see like why you get massively wrong? So there is this order. It guarantees that everyone gets the same graph and everything. Now, the reason I said that in that certain way is that it's literally the order of operations, if you want to think about it that way. The order of operations says this. This is the order of operations if you had an expression, right? You have to do anything in the parentheses first. So that makes sense. Horizontal shifting is in the parenthesis, right? When you actually write the function down, you want to do a horizontal shift. That +3 is in the parenthesis. So that makes sense. You have to do that first. Then you have to do any exponents that are on the parenthesis. Then you would have to do a stretch or shrink because that might be in the parenthesis. That, you know, the half and whatnot. We don't usually have exponents, but you'd have to do any things that are inside the parenthesis. Then, last, you do reflections because that's multiply and divide on the outside. So when I wrote this down earlier, I shouldn't even erased it. You're multiplying that function by -1. You're multiplying it by a negative. So you have to do the multiplying first before you add and subtract to move it up and down. Does that make sense why there's an order there? It's just the order of operations just applied to a graph. It will guarantee that everyone gets the same graph and you're not having this weird situation where you're way out. Like, I know it looks the same picture, it's just a translation's off, but you're literally, what is that, 13 spots off for where you should have been in the first place? That's even more than that, 14, 15 spots off. Like, it's a lot. Like, it's way wrong. So that's a big change in graph. So just make sure that it makes sense what you're supposed to be doing. They have to follow this order. So if you have a problem that has multiple items, you have to go in the right order. Okay, now, here's the thing I want you guys to get some input. Is there a certain type, like horizontal shifting or stretching, shrinking vertically versus horizontally, or reflecting, or, you know, there's two types of reflecting, or the vertical shift. Is there a certain one you'd like to see? Is there a certain one that, like, you do not feel comfortable doing it, you want to see another example of it? We'll walk you through it. And I'll do it for this graph, this generic one. Is there a certain one you'd like to see today? Because it's kind of up to you whether you can do it, whether you need more time. Yes?
Can you stretch again real quick?
Stretch, okay, you want to do vertical or horizontal?
Vertical.
Vertical. Okay, let's do a vertical stretch. Can you give me a number that you'd like to stretch it by?
5.
5. Okay, let's do 5 times taller. Okay. So this is what it will look like. This is a vertical stretch. Notice the number's not inside the parenthesis, correct?
Yeah.
So it's multiplied on the outside. So this is what they would show you. I'm going to go 5 times taller. I'm going to do it for my original graph here. Okay, hopefully I can make this work. I don't know if we're going to be out of bounds for some of these numbers. You might be. But we'll make it. Okay? All right. So if it hits the x-axis, like in this spot right here, you agree that it's an x-intercept. That number is not going to change since that's an x-intercept. The other numbers that will are all of the dots that are not on the x-axis. All of these dots will go 5 times further from the x-axis where they're sitting. So if they're above it, they're going to go 5 times taller. If they're below it, they go 5 times deeper. Does that make sense what a vertical stretch is? So like this dot's at 1, right? It's got to go 5 times taller. So it's actually going to be at 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There. Okay, so there's the first dot. That's moving 5 times taller. This dot was at 4. I have to go 5 times taller. I'm going to be up here at 20. It's got to be 5 times taller. Okay. This dot was at 3. I got to multiply by 5. It's at 15. Way up there. This spot was at 3. It's got to go up to 15. Because it's got to be 5 times, literally 5 times further than what that number sits right now vertically. And then this number will stay the same. This number is at 1, but now it's at 5. 1, 2, 3, 4, 5. So now we're at negative 5. Because it was at negative 1 or plus or whatever it is. All right, so now, graphing this is what it's going to look like. Now this is terrible, sorry. There you go. It's literally, I know it's terrible, I'm not nervous. It's 5 times taller. Like it's the same picture. It's supposed to be the same like igloo looking thing, but really tall. Make sense? Like how to do it?
Yeah.
Okay, that was good. Anything else you'd like to see?
So if you wanted it to, like when would you put a negative sign in?
Okay, so you want to do like across the y-axis or across the x-axis?
Yeah.
Okay, so which one would you like? Do you want both? You want, because it's up to you. Which one do you want?
The x-axis.
X. Okay, so we're going to go across the x-axis. Okay, do you want to do it on this picture or on the original one?
The original.
Original. Okay, so we're going to throw a negative on the outside. When the negative's on the outside, it goes across the x-axis. The y numbers have now changed, right? So I'm going to go after my original picture. Okay, so here's my original. And since I have the negative sign on the outside, all these numbers, I'll put it in a different color here, are now going to go across the x-axis and go in the exact opposite number across. So this was at 1, now we're at negative 1. If that's at 4, I'm now at negative 4. If that was at 3, I'm now at negative 3, and if that's at negative 1, now I'm at positive 1.
So what if there was a number before the negative and then the x?
Like this?
Yeah.
Okay, so now you're stretching it first, and then you're flipping it across. Because again, you have to stretch and shrink first, then reflect it. So let's say it's a 2, right? Because I can do 2. So you have a 2, this will be twice as tall. This is at 4, it'll be twice as tall, it's now at 8. This is at 3, now it's going to be at 6. This is at 6, and then this is at negative 1, so it's negative 2, right? That's twice as tall. But then they're all reflecting. So now they're going, like, we're taking all that, so if I want to draw that generically, there it is. Okay. But now I have to reflect it across the x-axis. So this dot was at negative, or is at 2, now it's at negative 2. This dot was at 8, now it's at negative 8. That dot's at 6, now I'm at negative 6. Negative 6. And that's at negative 2, now it's at positive 2. There you go. Make sense? That's good. That's really good. Any other ones that you'd like to see that you don't feel comfortable with and want to see again? If you throw the negative sign on the inside, that goes across the y-axis. So you'd go like if this, so if I had a negative sign here, these numbers go on the other side. These numbers come over here, this number goes over there, this number comes over here. So it just goes across the y.
So when do you shrink it?
Shrink it. Shrink it vertically, or you want to do horizontal shrink. Okay, let's do vertical first, so you can see it. Okay, vertical shrink. Let's go after the original picture. Okay, so vertical shrink is when they want to put a number out front, and they put a fraction out front of the parenthesis. If it's inside the parenthesis, they have to put a whole number. That's how you shrink it, like horizontally. I know that's totally backwards what you think it would be. But on the outside, if it's a 1/3, all the dots are exactly 1/3 as tall. So if that's at 4, it's now 4/3, because you divide every number by 3. This is at 3, I divide it by 3, I get 1. Divide by 3, I get 1. This is negative 1, I divide it by 3, I get negative 1/3. So here's what the picture looks like. It's just 1/3 tall. I know that looks super stupid and goofy, because it doesn't even look like the same picture anymore, but it's 1/3 as tall. You're compressing it. Even though all the X numbers have stayed the same, the Y numbers have now changed 1/3 as tall. You're compressing. Okay, that help you out? Okay, that was good. Any others you'd like to see? Just to make sure we're on the same page, you feel comfortable graphing. Okay, and again, I can go over any type of graph that you want, like if you're not comfortable today. You do have a small assignment today that I'm going to give you. You'll need graph paper for that, so I'm going to hand out graph paper. If you don't have any, some people like have multiple pages of graph paper. And you'll need graphs for all these. We're going to be graphing exactly 12 pictures again. Exactly 12. You only have to do one picture per graph. Okay, does that make sense? I do not. I don't. Bless you. But you don't have to draw the original one if you don't want to, before you translate each picture. Does that make sense? Or you do something to it. If you looked at mine, because I'll have the answer key as well, I will actually draw the original. So I always like to see what the original is, because I have to see what those numbers are doing. It's just one of the things I do. So this is what my pictures would look like if you're seeing my homework. Because I like to see what the original is, and then I use those numbers to figure out where to go from there. So, all right, let's get to our graphs today. Okay, let me hand out some graph paper. I'm going to put the problems on the board. There's only 12 today. We do on Monday. Yep, due on Monday. Yes. Yeah. Madeline, if you want to go grab your little paper, you can. And Drew, I can give you your 4 problems.
I remembered.
Okay, perfect. So you can put it on my desk, put your name on it. Oh, she's very good. So you just put it right there. Okay. Put your name on it. We're good to go. All right, here's your homework. This will be due on Monday. So hopefully I'll give you enough time today. And again, if you have any questions, like you don't understand a certain type of transformation, you want to see it again, don't be afraid to ask. That's the whole point of doing this today. Yep. So make sure you're taking your time to do that. All right, homework today. All right, here we go. Okay, page 216. Page 216, we're doing 22 through 32, the evens. We're doing 34 through 44 evens. There you go. It's exactly 12 problems I covered. That was good. Thank you for all those questions today. Sometimes you just got to do that. You got to figure these out. Well, yesterday we had enough examples yesterday to kind of hopefully help you figure those out. And again, on test day, on this stuff, you definitely get that list, the order you have to go in. The problem is you have to know what to do.